What's up, math scholars? We are going a whole different direction in life with chapter 6. We'll be doing like statistics and combinations. We'll do a little bit of a project when you get to survey your classmates and then make a chart from the results, so that'll be fun. But yeah, you need a calculator out on your desk today, so who's excited to learn about combinations? Wow, that was no enthusiasm at all. Let's try again. Who's excited to learn combinations today? Woo! They're looking grumpy on a Wednesday day. No one's smiling. Okay, one person is smiling. Two people. Two people are smiling. And today's not Friday. Maybe that's why they're grumpy. Okay, so the warm-up we did was technically called a permutation. That is not what we're learning about today. That's when order does matter, such as I have 20 baseball players on my team. How many different lineups could I come up with? That would be order does matter. But what we're going to be doing today is when order does not matter. A little different. Such as I had 30 vegetables, I want to choose 5. Order wouldn't matter. What order I would choose them. And we all have the calculators ready to rock and roll. I'm going to show you some buttons today. Okay. So we did that as a warm-up. Oh, go back. Yep. All right. We have 4 letters here. C, A, K, and E. And I want to see how many different combinations of letters I can come up with. Now, order doesn't matter. I just want a collection of letters. All right. So if I'm going to choose 3 from those 4, I could choose C, A, and K. I could choose C, K, and E. I could choose A, K, and E. And I could choose, what am I missing? A, C, and E. C, A, and E. Yeah. K, A with E. K, A with E. E, A with K. The answer is 4, though, so I feel like if we were coming up with another one, I have one on my list twice. The answer is 4. Okay. So what technically happened here is we had 4 objects and we chose 3. Okay. Make sense? Yeah, I'll be showing you shortly. There's a formula. It's called a 4 choose 3 formula. Okay, 4 choose 3. All right, first of all, before we get into the formula, I want to talk about what a factorial is. I heard it came up on the ACT yesterday. It was purely coincidence that you were learning about it today. Purely coincidence. So it's called factorial, and the true meaning is that you take the number and you multiply it by every integer, or every whole number actually, smaller than the number, down until you get to 1. So technically, those are called the natural numbers. Natural numbers. All natural numbers smaller than the number. Yeah, there's a button. I'll show you where the button is too. But that would be 20 times 3 times 2, so it's 120. All right, I'm going to hit pause so students can ask questions. All right, so let's talk about where the factorial button is located. Let's try a new problem, maybe 12 factorial. So you're going to hit 12 first in your calculator. Then you're going to hit the math button. It's in the math menu. I hit the left arrow to get to the PRB menu. Depending on what calculator you have, if you have a color calculator, I think you have to hit the left arrow twice. But then it should be the 4th choice down. Looks like an exclamation point. Holy smokes, I better borrow Elizabeth's calculator because that number's so big. 479001600. So call me over if you can't find a button, or talk to your neighbor if you can't find the button. It's called a factorial button. So let's go ahead and write down what NCR means. This means I have a certain amount of objects, and I'm going to choose a certain amount of objects from those objects. So in this case, I have 5 puppies to choose from, and I'm going to choose 2 puppies to take on my trip. The question would be, how many different combinations of puppies could I come up with? So here's how the formula works. I already put it on the board. I'll let you write it down, and then we'll stick some numbers in with our example from. Okay, so let me explain how we're going to use the formula to do 5, choose 2. Five puppies, I'm going to choose 2 for my trip. The number right here, which is my 5, will go on top with the factorial. On the bottom, you will do n minus r, so 5 minus 2, and put that as a factorial, so it will be 3 factorial. And then you will do 2 factorial. Now this is a really small one, so I'm going to show you how these numbers can cancel. When we get to really big ones, I'll show you where the fancy button on the calculator is. So on the top, we do 5 times 4 times 3 times 2 times 1. On the bottom, 3 factorial is 3 times 2 times 1, and 2 factorial is 2 times 1. So you get a lot of cancel action happening here. 3's and 3's can cancel. 2's and 2's can cancel. And 1's and 1's can cancel. It looks like I have a 20 on the top, 5 times 4, and a 2 on the bottom, 2 times 1. So I can come up with 10 combinations of puppies to take on my trip. But it didn't cancel. Mm-hmm. That's it.
We have to write it though? Like, or can we just put that in the chart?
Yeah, there is a way to just put it in, but since this is our first one, it's kind of my math teacher duty to the world to show you how the factorials work and how they cancel. Yeah? It does. So I just did this part in my head. So the 5 went here, that's n. N minus r was 5 minus 2, which was 3. And then r was 2. But we're going to do a couple more the old-fashioned way before I show you how to cheat and use a calculator. Just to get a handle on how the factorials work. Probably not. Okay. I have 17 chickens. I need to take 5 to the fair. How many different combinations can I come up with? We're taking some chickens to the fair. So how could I write this out with my, object, choose object, with my big C?
17, C5.
Good. I have 17 chickens. Oop, that needs to be a 17. I'm going to take 5 with me to the fair. Nope, you can't take them all to the fair. You can only take 5. So we're going to use our factorial to do this. It would be a 17 factorial on the top. On the bottom, you would do 17 minus 5, which is 12 factorial. And then you'd have a 5 factorial. So we need to talk about who would cancel and who would not. It's going to be kind of long. 17 times 16 times 15 times 14 times 13 times 12. And I'm just going to write everything else as 12 factorial. Now I have a reason for that craziness. Do you know what my reason is? On the bottom, we have a 12 factorial and a 5 factorial. So this will cancel. Now I want to show you something cool about 5 factorial. What does 5 factorial mean? 5 times 4 times 3 times 2 times 1. Correct? I want to show you some really, really, really cool factor trick. Do you agree with me that 5 times 3 equals 15? You can actually do 5 and 3 and cancel it with a 15. Are there any other combinations of numbers that would multiply and cancel something? Not that I see. But we could do 16 divided by 4 equals 4. And we could do 14 divided by 2 equals 7. That'll save some typing. So here's what we're going to type. Everybody type it with me. 17 times 4 times 7 times 13. So if you didn't follow the crazy canceling, please don't panic, because I'm going to show you where the button is that'll do this one for us. 6188. You ready to learn where the button is to do it for us? It's also on the PRB menu. So you'd hit 17 first, then math, left arrow to get yourself into the probability menu, and it's choice 3. And then you'd have to type that 5. Hot dog, we also got 6188. Sweet. You can save all that crazy canceling. It's my teacher job to show you the crazy canceling, but hey, I realize in the real world on your quiz, you're going to be using the calculator.
Or in the real world.
Or in the real world when you have a job and you're learning about it. Yeah, it's going to be the third choice. 17 first, hit the 17 first. Pause this. The pizza parlor has 10 toppings and you want to choose 2. How many combinations could you come up with? Pepperoni and sausage, or black olives and peppers. How would I write it with my C? 10, choose 2. 10, choose 2. So let you use that fancy button in the calculator. Type that one in. What'd you guys get? Awesome. So 45 different 2-item pizzas. Alright, so I have learned through teaching math that some people have play cards a lot and they are really knowledgeable about what is in a deck of cards, and some people never really play cards and they're not very knowledgeable about what is in a deck of cards. So depending on what you know and what you don't know will let be what you need to write down and what you don't need to write down from this slide. So I'll pause the video and kind of discuss decks of cards and let people write things down. Alright, we're going to answer a few questions about a deck of cards. It says a standard deck has 52 cards, 4 different suits, and 13 different cards in each suit. If the order in which the cards is dealt is not important, how many 5-card hands are possible? So choose what would I want to write down here? 52, choose 5. And that's how many 5 card hands you could come up with. It's a big, big number. I'll write it down and you look up here to see if your answer matches mine. 2,598,960. Okay. How many possible 5-card hands would consist of all face cards? So what you need to determine is how many face cards are in the deck, and then choose your 5 from them. Do you know how many face cards are in the deck? 12. The 4 kings, the 4 queens, and the 4 jacks. So from the 12 face cards, we would need to choose our 5. And then that would be our answer. 792. And then how many possible 5-card hands would consist of all red cards? So you need to come up with just the red cards, which there's 26 red cards. And you need to choose your 5 from those 26 red cards. 65,780. All right, we are going to talk about Shakespeare next. And talking about deciding if we need to multiply or add when we calculate out problems. Find it? Up here it was. William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38, 18 are comedies, 10 are histories, and 10 are tragedies. Let's start with part A. How many different sets of exactly 2 comedies and 1 tragedy can you read? So I basically have to make 2 decisions here. I have to choose 2 comedies from the comedies, and I have to choose 1 tragedy from the tragedies. And those 2 events will be multiplied together. This is kind of what I was talking with Lexi. Remember when you were choosing books out of the suitcase? When you make more than 1 choice, you end up multiplying the events together. So let's start with the comedies. How many comedies are there? There's 18 comedies. I need to choose 2 for me to read. And how many tragedies are there? 10, and I need to choose 1 for me to read. These are 2 separate events. I multiply them together, get my total combinations. 1530 is what I have on my paper. Is that what we got? Now this one's a little bit harder. How many different sets of at most 3 plays can you read? Now when you see the word at most, it is very tricky. If you want to read at most 3 plays, you could read 3, right? But you could read 2. But you could read 1. Or you could read none, right? And it's an or situation. Since I could do one or the other, and if it's one or the other, you end up wanting to add. If you're definitely doing both, you multiply, but if it's one or the other, you add. So let's start with, what if I read none? I have 38 plays, but I'm going to choose none. That's the first one. Or I could, from those 38 plays, choose to read one. Or from those 38 plays, I could choose to read two. Or from those 38 plays, I could choose to read three. And that's the different, all the different combinations of sets I could do. Well, that's a lot of typing. I'll give you a second to type. You have to use that, fetch that big NCR button for separate things. Oh, right. You could just grab a button. The TI-85s, the old ones, had that. They had what was called a custom menu. So all the buttons you used a lot, you would put in your custom menu. So in my custom menu, I had the factorial button, I had the fraction button, I had things like that. I think they don't have that in the new calculators. Well, I used an 85 back in high school. Back in the day. Before you guys were born.
Yeah.
They did. They went from 85 to 86. We used 86, then when I got my job here, now they're using mainly the 84s.
Well, then why the 80s?
All right, I think they all typed that in finally. It does take a while. 9178. Okay. I'm going to look to see what problem I think we should end with. And I'm thinking the pumpkin problem, okay? Yep, of course. Ready? Everyone ready? Okay. Christy Harp has grown 25 fruit. 10 are squash and 10 are pumpkins. Oh, my bad. 10 are squash and 15 are pumpkins. I always anticipate somebody say, they're not fruit, they are. Lexi knows because she's in horticulture class. It has to do with where the seeds are. Fruits. Okay, sure. I don't know. Fruit? Or fruits? Fruit.
25 fruit.
I use the word fruit when I say plural. Like, I have 10 fruit in my basket.
I say,
We're going to Google that. Attention, internet. I'm not an English teacher. We will look that up later if the plural of fruit is fruit or fruits, but let's move on. How many different combinations of exactly 5 squash and exactly 8 pumpkins can I take to school? So I definitely have 2 decisions to make, so I'm going to be multiplying here. I'm taking 5 squash to school, so how would I set that up? 10 choose 5, because I only have 10 squash to choose from. Then how can I choose 8 pumpkins? 15 choose 8. Go ahead and type that in. Let's see what you get. We're live on the internet right now. Oh gosh. This is what I got, unless I typed it in wrong. 162160. Okay. And then this is very similar to the Shakespeare one. How many different combinations of at most 2 fruit could I bring? So I could bring 2, or I could bring 1, or I could bring none. So the word or means to use that plus. I might do one or the other. I'm not real sure yet. So how would I set this one up? 25, choose 0. That's if I bring none to school. That wouldn't be fun. Or I could bring 1 to school. 25, choose 1. Or I could bring 2 to school. 25, choose 2. We're going to type this in, grabbing that NCR button 3 times. Lexi did this first. Thank you very much. She got 326, so call me over if you didn't get that. I'm going to stop the video. Thanks for joining along, everybody. And your homework is a worksheet that I'm passing out in class. And if you're watching on the internet, just go into Polaris, and the homework would be the last 2 slides of the notes I have saved. Okay. Bye-bye.